Swayam Prabha. Digital India. Educated India.
Hello all, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. We are covering module 4, lecture number 34, where we are covering orthographic projections part 2 and especially the line projections. In this, earlier we tried to look at if a line is parallel to one of the plane, perhaps making an inclination angle with respect to the other plane, how to draw those lines, whether it might be in the first quadrant, second quadrant, third or fourth quadrant. We try to look at its projections, where one of the condition is the line is parallel to one of the planes. If that violates, for example, in general a line which is inclined at different angles with the vertical plane and also the horizontal plane, then how to draw its projections. There we will ask different questions. If a line is known, what is the angle it is making with the planes, we know how to draw projections. The second question what we will ask is, in case if we know the projections, how to find the true length of that line. So, the second question, by knowing projections and constructing the true length is always be slight complication involved compared to the case where we know the true length and inclination angles made by that, so that we can construct projections. Both the cases we will try to look at that in our today's class. Let us begin. Let us pick a AB line . This one, and if we are seeing by projecting this A all the way down, we get A on the horizontal plane. By projecting B all the way down vertically, we get B. This is the projection one. It makes an angle maybe beta or theta with the horizontal plane. Similarly, let us project A, B points onto vertical plane. It makes A prime and makes B prime, so that the projection line is this. And this one, when we are looking at that with respect to the horizontal plane, it makes an angle alpha or phi. These two angles, the beta or theta, these two angles may be different in general. If that is the case, how to draw the projections of this line? That means, can we draw on the vertical plane the A prime, B prime and then project it maybe A and B. The AB is not a true length, neither AB is true nor A prime, B prime is true length. The true length always be AB. So, if I know the projections, how to get that? Inverse problem 1, or if I know these angles and true lengths, how can I get this A prime, B prime? These are the questions what we will ask. So, the angle made by this true length AB with respect to the vertical plane, that we will get it in the top view, and the angle made by this true length with the horizontal, we will see it on that vertical plane or in the front view. These are the directions what we will see. For example, this angle with respect to horizontal, we will see it here, and this angle, the projected one, with respect to vertical, whatever the angle is going to intersect this vertical plane, whatever that angle we are going to see, that we will see it here as beta. Let us ask a question. When front view and top view are known, how to find true length? For that, let us begin this story. Already we might be knowing these front view and top view things, and from there we would like to construct this true length. For that, what we have to do? Let us assume we know already A prime, B prime, and we know because if we want to construct A prime, B prime, we need to know how far this A prime is located, then what is the angle it is making. In the last class what we have learned, angle made by that, we go ahead, cut it there, make B prime. Similarly, project A prime all the way down, so that we will get A, how far it is in front of this vertical plane, then project B prime, then rotate it in such a way that whatever the angle it is made, that we will locate it. So, somehow we know this front view and this top view also we know. If that is the case, how we are going to construct a true length is, use AB, rotate it such that construct B2 line. AB is apparent, A prime, B prime is also apparent. Somehow we have already constructed A prime, B prime and AB. Once we know, use AB, project it back this AB onto horizontal plane to locate B2. It is more like getting this AB2 line. Once this AB2 line is known, we again project it back all the way up. A prime, B prime line already known. So, B prime line we project it to get B1 prime. Once B1 prime is known, A prime to B1 prime, connect it, and that is the true length. This is the way we construct this true length. It is more like when we have this projected line in 3D, let us look at this. We already have AB thing. What we want to do is project that one, rotate it by horizontal direction. That means, this length we want to really rotate it, so that we will be in a position to mark a point somewhere there. Then transfer it all the way up. Then extend this line, so that we will be in a position to construct that true line. Then rotate it back. Then we will be in a position to get that AB line. This is the way we construct it. The same procedure geometrically Here we are doing it in that way by rotating it, so that I will get AB2, then transfer that AB2 all the way up, then extend this line, get this one. This will be the true length. First true top view is rotated, made parallel to xy line, is corresponding front view A prime A B1 prime, we will get it A prime B1 prime, and that shows the true length and true inclination angle with horizontal plane. Let us ask another question. When true length is known, how to locate front view and top view? So, for that purpose, what we have to do? We know the true length and we know the inclination angle made by the true line with vertical plane and also horizontal plane. This is pretty straightforward problem. What we will do? Somehow we already know the true length and angle made by the vertical plane, horizontal plane. So, with vertical plane angle, what we will see it in the top view, and the horizontal plane angle we will see it in the front view. So, true length we know, with theta angle with the vertical plane, construct it. Once we know the true length, constructing that A prime B prime we know. That is done. Similarly, A B also we know true length, we construct it with certain angle phi. Once this true length is known, we project this all the way down. When it is done, we rotate it by 90 degrees all the way to construct phi angle, so that it is going to intersect at that point, and we will be in a position to construct true length in the top view. So, let us do it once again. Once we know this true length A prime B1 prime, we project that all the way down, where we are going to construct this true length line towards top view line, rotate that all the way to top view line, which is making an angle phi, and we will be in a position to construct this AB. Once AB line is there and already true length line we know, project it back all the way up, up to here, rotate it all the way there, so that we will be in a position to construct this front view. Let us do that by picking an example. There is a line AB 75 mm long, and it is 30 degrees and 40 degrees inclined to horizontal plane and vertical plane respectively. End A is 12 mm above HP and 10 mm in front of VP. First of all, visualize this point AB may be in the first quadrant, 12 mm above HP and 10 mm in front of VP. And this true line 75 mm, it can be in any direction from that point A 75 mm, but it is supposed to make 30 degrees to horizontal plane and 40 degrees to vertical plane. That is the direction along which we will locate the point B. Sorry. Let us look at the solution. First of all, we have to draw xy line. Let us draw this xy line. Then locate 12 mm above xy line. For A prime, we are locating 12 mm and 10 mm below xy line also, because we are going to rotate that horizontal projection. So, below that will be 10 mm, because that is the direction in front of VP which we are going to rotate it. So, we have located this A also. Let us use some other color, magenta. We know A, we know A prime. These points are known. Now, what we have to do is 30 degrees with respect to horizontal plane, which we will see it in the front view. So, take 30-degree angle from A prime. So, 30-degree angle a line we have to draw in such a way that we will be in a position to mark true length 75 mm. So, the 75 mm, a line we will draw at 30-degree angle and it stops, call that one B1 prime. Similarly, pick 40-degree angle and locate this 75 mm length. So, from A, draw 75 mm with an angle of 40 degrees. Both the lines we know. So, point we will locate B1 and B1 prime. Now, we have to draw horizontal component of this true length. So, let us call this one true length. This is also true length lines. Once we have that, a horizontal component of true length AB1 we are going to draw from point B1. So, project this one all the way up to get horizontal component. A B1 from point B1 and name it 1, somewhere we are going to name it. Then length A1, if we are similarly, let us do it from B1 prime also, horizontal component 1 and 1 prime. If we are looking A1, this A1 length we have to rotate it. So, if we are picking this A1 compass, draw an arc, it goes via that point. Similarly, project this one radially in that direction. So, it makes another arc. Extend it up to the locus of A and rotating A prime as center, locate B prime as shown. Then join A prime B prime in the front view. So, what we have to do is, here we are going to rotate in such a way that this B1 we extend a line to locate B prime there. Similarly, this B1 we are extending in such a way that we locate B prime. Once these points are known, let us use some blue color. B point is known by extension of this line, B prime is known by extension of that line. We can connect it to get these apparent length lines. This is A, this is A prime. So, this will be the front view and this will be the top view of the system. Let us repeat it once again. First, we have to identify this true line making an angle. Similarly, identify true line making an angle, project it all the way there, rotate it. Similarly, project this one all the way up, rotate it. Already we know this projection B1, extend it to make cut. B1 also we know, extend it, make a cut. Once it is done, we connect these lines to get front view and top view. Let us practice this example on the drawing sheet. After that, we will summarize the finding. So, the first thing as a practice, draw a xy line. This is the xy line. The first step is identify true line 75 mm. For that, we have to locate a prime point, which is 12 mm above xy line. This is x axis, this is y axis. Somewhere here we have to locate 12 mm. So, 10, 11, 12, somewhere here. So, let us call this prime as A prime. We have to take 30 angle from A prime. So, let us draw a horizontal line also here. And there 30 angles we have to locate. Join these lines. And what we have to locate is 75 mm. Locate that point. This is our true length. So, join, call B1 prime and join these lines. Similarly, let us locate the true line in the downward direction. For that, we have to project point A, and that is supposed to be 10 mm below xy line. So, this will be our A point, and that is supposed to make 40 degrees with horizontal. 30, 40 somewhere there. So, if we are joining this line, it makes an angle in that way. Call this point our B1 and join this one. You see B1 prime, B1 will be different when we have these projections. True lengths are done. Now, what we have to do is project these true lines all the way down. Move parallel all the way down. Similarly, project these lines all the way parallel. So, on this projection, mark that one which we have to transfer. Let us mark that one as 1 and 1 prime. So, transfer this length in that way. Similarly, transfer this length because it is projecting onto a thing here. Something like that. That we have to project it all the way from this point. So, project it in that way. Once we make arcs, it is quite easy for us to extend these true lines. This must be the true line, extend it in that way. From B 1 prime we have to really do, and similarly mark an arcs which are going to intersect. So, this one will be intersected there, join this line, this will be apparent one B prime. Similarly, we have to extend B 1 prime in such a way that this length will be rotated. So, it is going to make it here. If we are joining those lines, and this one will be our AB. And let us find what are that lengths. So, the projection length. So, let us note it down. This is vertical plane, this is horizontal plane, and what we are interested is the projected lengths, how much they are. If we measure that, it will be 61, 2, 3, 4, 64 units. So, 64 units we have to mark it. So, this will be parallel to AB line. And this will be our 64 units. Similarly, A prime B prime line, it is 39 units. So, parallel to that, if we are marking this will be 39. So, when a line is inclined to both vertical plane, horizontal plane, we have to use these kind of projections to construct this front view and top view of the system. Let us look at more problems in the next class.